Hello guys, we are continuing the fourth video for gate quick formulas. So please be with me. These are the formulas I studied during my 2022 gate exam, and these are the formulas mainly from I took from the unit operation website and from solutions from various sources like I told you, like from unit operations and YouTube solutions, and some of my own, like I took a coaching from the Gate Coach. So questions solved there during the classes. So I took the important formulas and I'm writing down for you so that you can get an insight about the formulas or quick formulas, or which the formulas which were used so frequently in the gate exams during these last 30 to 40 years. 30 years means mainly from 1990 to 2021. PYQs. Okay guys. Tube manometer. Tube manometer has a second order process. Conductivity meter. Conductivity meter we use to determine the composition. Turbine meter for to determine the flow. Concentration we can calculate through chromatograph. So guys, these are the direct formulas. So no one can understand directly what I am teaching here now. So please go through the for depth knowledge. Please go through the source books of respective subjects. Okay, source books for for depth knowledge. So I'm not explaining everything to you guys, just I'm writing down the uh, formulas for the gate exams which was used in the last 20 to 30 years for every subject. I'm just writing them down. Okay, so Q, as we know, Q has a meter cube per hour, its units. So PI controller transfer function is defined as controller C for controller transfer function. This is the ratio of product upon input. So this is the simple product upon input function. So okay, GCS is defined as Kc 1 plus 1 by tau I s. Kc is a proportional controller, okay. Kc is known as gain. The characteristic equation be defined as 1 plus Gc Gf Gp Gm is equal to 0. Okay. Okay, overshoot is a by p. It is defined as exponential of minus pi by pi into zeta root 1 minus zeta square so okay, like this. Okay guys, so this is a and this is b. Okay, this is second order only. Period of oscillation is defined as p is equal to 2 pi tau 1 minus zeta square. This is a period of oscillation. Okay. Liquid level in a tank can be determined by capacitance probe. So this word is related to this. So it was asked in the GATE exam somewhere. So I wrote it down. Okay guys. So GS is YS by XS. Yes, okay. This is response. This is input. Okay. Find AR from transfer function GS. Okay, GS is a transfer function. So AR, if we find AR is equal to G iota omega second order. AR is equal to 1 plus root tau 1 का square omega square. Sorry, this is okay, tau 1 का square and then omega square, then this 1 plus tau 2 का square, then omega square. Okay, this is for second order. Okay, this is for second order. decay ratio decay ratio is defined as like decay ratio is defined as OS का square, it's overshoot का square. So overshoot we wrote it down like before just a minute ago. Okay, AB is equal to exponential by zeta by 1 minus zeta square. So so decay ratio comes out to be like exponential minus 2 pi zeta by 1 minus zeta square. Zeta is like 1 0 to 1 as specific meaning. Okay, if a characteristic equation is given, then uh, if some characteristic equation is given like a naught s cube a1 s square a3 s. Wait, sir. So guys, like, and this equation is given a4 is equal to 0 characteristic equation. So when we write like a naught a2 a4 a6 a6 1 2 3 4 5 5 rows. So a1 a3 a5 a7 b1 b2 b3 c1 to c3 1 d2. So b1 we can find like a1 a2 a naught a3 first, then second. So a1 a2 a naught a3 by a1. Okay, so this we do for stability, the test for process. All elements of first column should be, these all first column elements should be positive, and non-zero. So linear variable and variable differential transformer is used to displacement meant to voltage meant to voltage. We know that for second order transfer function is defined as k by tau square s square plus 2 zeta s tau plus 1. So roots comes out to be like minus zeta by tau plus minus zeta square minus 1 upon tau. Okay, for like underdamped is when zeta equation lies between 0 to 1. As we know, offset comes in a closed loop, not in open loop. Some important, like we should remember these things. We should remember like AR is equal to 1. This is for pure dead time. This is amplitude ratio. For pure capacitive system, phi is minus 90. Inverse response is k1 by s minus k2 by tau s plus 1. ठीक है. नेक्स्ट first order process with the unit has amplitude ratio between 0 to 1. Offset we can define as VYSP infinity. YSP is input given minus y at infinity. YSP at infinity, limit s tends to 0 as YSP as y limit s tends to 0 as ys. Okay, ys p, this is a transfer function which can be gc gf controller transfer function, gf gp process transfer function plus gc gf gp gm measuring device transfer function process transfer function, first order transfer function, controller transfer function. Rise time is defined as Tp is pi tau by 1 minus zeta square. 1 minus zeta square. As we know, thermocouple senses temperature based on the Seebeck effect. Equal percentage valve is defined as Q is equal to CV delta PV by G. CV is defined as valve coefficient. This is unit is Gale minute PSI 0.5. F fraction is defined as Q by Q max. X is 0. Like when F equal to F minimum 1 minus X. X is well is not open. Okay. Or sometimes people write like FR L minus 1. F minimum flow when hole is closed, fully closed. Flow rate when fully closed valve. So F minimum R L n minus 1. Sometimes we say this is lift L. G is defined as specific gravity. Equal percentage well. Equal percentage well is defined as D by 5dx beta f. Ln f is equal to beta x plus integration constant fraction of maximum flow f is equal to f by f is equal to q by q max. Fraction of maximum flow. Fraction of maximum fraction of maximum lift. F is equal to F naught e की power beta x. Q is equal to q naught की power beta x. Percentage well. We studied non-interacting tanks, non-interacting tanks. So H2S by QS is 1 plus 1 R2 I2S plus 1. Non-interacting tanks are like this. Non-interacting tank. Tau 1 is defined as R1 A1 tau 2 to A2. Gs is defined as 0 to infinity e की power minus st function t minus tau dt. Solution of type of is 0 to infinity e की power minus s t plus tau f tau t tau minus s tau f s tau is equal to 3 f t is equal to 1. Gs is equal to minus 3s by s. So like if 0 to infinity e की power minus 3s and fs is equal to 1 t tau. So Gs solution comes out to e की power 3s by s. Initial value theorem is defined as limit t tends to 0 y t limit s tends to infinity s by s. Final value theorem defined as limit t tends to infinity y t s tends to infinity y s. So further we know the formula ln r2 by r1 is equal to e by r 1 by t1 minus 1 t2. ln t1 by t2 ln K2 by K1 is equal to ln R2 by R1, all equal to this formula. E is in joule per mole per Kelvin. R universal gas constant, joule per mole Kelvin. If A K1 K2 A से B to A minus RA, we know that minus dCA by dt is equal to dCB by dt. CA is defined as CA naught as XA. This is conversion. For CSTR, we can write in equation tau by CA naught is equal to XA by minus RA. Okay, guys. Empty Thiel modulus L is length of pore, K is reaction rate constant, first order, D is equal to diffusion constant, empty, then define through formula L root K by D is a rate constant, and this is diffusion constant. Tau is in second, F flow rate is in meter cube per second. Okay, meter per second. Tau is equal to volume, meter cube denoted by V upon F, or V, meter cube per second. F can be mole per second. Usually this is V and this is F, mole per second flow rate, and as per the conditions we can denote them. Okay, so not a big deal. For CSTR, ET equation is defined as 1 by tau CSTR की power minus t tau CSTR. Okay, ET is 1 by second. Okay, flow through a smooth pipe is defined as delta PF is equal to 4F rho L V square by 2 dg. Okay, this pressure drop. Okay, this is for turbulent flow regime. Delta P is equal to rho GH. Pressure drop vary with height. Variation with height. We know in fluid mechanics, Bernoulli's 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 theorem, like 1 by 2 alpha is V2 square average minus V1 average square plus G Z2 minus Z1 plus P2 minus P1 by rho plus frictional losses plus shaft work, okay, is equal to 0. So all the term on left side, and this is 0. This is frictional losses. See shaft work. Alpha is 1 for turbulent flow. Alpha is equal to 2 for laminar flow. Okay. Shaft work comes out to be negative. In this shows that energy added to fluid. Okay, when shaft revolves, shaft revolves, then energy is added to the fluid. Okay. One important thing: 1 meter cube is defined as 1000 kilo. Okay. Flow over a plate can be defined as Knowles number rho Vx by mu x is a distance from edge of plate. Okay. Power required to deliver the fluid is M W as shaft work, and this M is like mass density upon volume. So this so mass this 10 mv, if we mv We can take V in terms of flow rate, M mass, and WS. We can convert these formulas as per our requirements, as per given in the question. Okay. Friction factor is defined for laminar flow is 16 by Re for laminar flow. Laminar flow F star is 4 times of F, so 64 by Re. 64 by Re. Okay. Now we see the Venturi meter devices for fluid mechanics. Venturi meter rho manometric fluid, rho is equal to vanometer fluid. Vanometer is like this converging from the center, then again diverging. Okay, this is 0.1, this is 0.2. V2 is equal to CD by 1 minus D2 by D1 by 4 to delta P by rho. Okay, then further we can find Q value V into area. Okay, this is meter cube by second, so V velocity for discharge at 0.2, so A2 V2. Okay, so Q1 A1 discharge at Q1 A velocity at 0.1 V1. Okay, steady laminar flow in pipe. L by D equation 0.05 by 0.05 into Re. Assumptions, this is allowed for only in compressible fluid and Newtonian fluid. K by D is defined for roughness factor. K by D increases, F increases, friction factor increases. Okay, for fully developed flow from integral momentum analysis for turbulent boundary layer. For fully developed from integral momentum 0.376 RE 1 by 5 for turbulent. This from fully developed for integral momentum analysis delta. This is boundary layer thickness. Power law equation for non-Newtonian fluid. Tau is defined as K minus dV upon dr की power n less than 1. Tau is defined as mu apparent viscosity minus dV upon dr for Newtonian fluids. N is less than 1 pseudoplastics. ये mu apparent is K into minus dV upon dr n minus 1. Pascal is kilo by meter second square. K is equal to watt delta T by L by Ka. Okay. Reynolds number P is less than 1. This is for Stokes regime. And so ut is defined as g dp square rho p minus rho 18 mu. Rho p is for particle density. M by AI is u rho. Then rho u, and rho u is defined as g with another notation. M is u rho and then area. Then this is area. So this, so u has second term. Two packed to packed tower to width t1 and d2 decide by gas velocity. So this G na G1, this can be useful rho 1 rho U2 for two different packed pad. Delta P by L G1 minus epsilon m rho P minus rho. This is minimum fluidized condition for fluidized bed for packed bed reactor. This is pressure drop per unit length. K has a value watt per Kelvin. Q has delta T by L by Ka. In radiation we know A1 F12 A2 F21 view factor. For condensate on a vertical plate and a laminar flow of condensate is defined as Nusselt number 1.13 rho L minus rho V G H F G L cube by mu L K L del T. This is raised to power 1 by 4. So Nusselt number is a condensate. Delta T1 is 100 minus 10. This is plate temperature and this is top vapors temperature. So heat removal in mixing defined as Q out NiHi minus in NiHi plus delta H mixing. negative sign indicates heat to be taken out of the tank. So this flow term, this H value, enthalpy is related to flow. So out minus in plus mixing, change in mixing. Okay, U has a meter square degree Celsius, and this is overall heat transfer coefficient. I intensity is defined as 0 to infinite I p lambda d lambda. Liquid heated with steam. Heated with steam coil. Liquid heating steam will change in internal energy of liquid. So we assume that all the heat comes from the steam coil, goes into increasing the temperature of the liquid. Okay, mCp dt by dt. Okay, so UATS minus T, this is coil temperature, and this has a unit wattmeter. So this contains second time term. This watt is joule per second. Okay, sorry, this is degree Celsius. Okay, so joule per second. Coil temperature, this coil temperature, this is liquid temperature. So this is rate of change of dt by dt, rate of change. Economy of evaporators is defined as kilo of water vaporized, kilo of steam supplied. Okay, local heat transfer related to Fourier equation by K by del T. Okay, H bar is defined as 4 by 3 Hx. So also condition Q Qx by A is equal to Hx T whole minus T surrounding temperature minus K dt by dy y is equal to 0. Delta T Lm is defined as delta T2 delta T1 upon ln delta T2 upon delta T1. For sphere, temperature profile is defined as T is equal to T whole plus Q uh, generation R square by 6K. Lump heat capacity is defined as like T final T surrounding T initial minus T surrounding cell minus HAS by PS rho S into T. Heat capacity. So formula for cylinder T max TW and this side X. Let's consider heat generation is taken place inside a cylinder in the form of watt per meter cube. So T max is defined as Q R square by 4K plus TW. Here this is a wall temperature, means this is a sphere R, this is T wall temperature. So here also T max we have to find. So Q generation R square upon 6K here as 4K. Addition rule. Addition rule is F11, F12, F13. Okay. Alpha is K by rho C. Fin extended to infinite length. Square theta by dx square is equal to m square theta. So theta is C1 e की power mx, C2 e की power mx. T final minus T surrounding, T initial minus T surrounding e की power mx. Fin we know extended infinite, extended. T naught is temperature, this is x. Alpha thermal diffusivity is defined. This is thermal conductivity, thermal diffusivity. Rho g thermal density and capacitance. As we know, like Kirchhoff's law, alpha is equal to emissivity, alpha is absorbivity, and this is emissivity. Energy has units watt per meter square. Q has a unit watt. When we define 1 to 2 energy heat from 1 to 2, then rho AF1 to view factor. This is a view factor. Ti power 4 minus rho A F21 T2 raised to power 4. Okay. Net rate of radiation heat transfer Q AIJI minus GI. This is out and this is in. This is in term. So this is absorb PVT coming from thin plate. Not other plate. If a single black body single black body emits a radiation, then heat is defined as Q EBI minus J. This is out term means out term radiosity, we call it as radiosity. Okay, this energy This is energy entering drain. So resistance defined as ln I ai ln I. Okay, so energy entering minus energy out. This is surface resistance for radiation. Q I j I minus j upon 1 upon ai f I j. This is medium resistance. Total energy leaving by black body J is equal to rho G plus epsilon E B. Epsilon is defined as E upon E naught. This is emissivity. This is reflectivity. There is a relation rho plus alpha plus is equal to 1. Reflectivity absorbivity emissivity. Now we discuss the mass transfer formulas. Yn plus 1 r by r plus 1 xn xt upon r plus 1. And this is n enriching section line equation. Y counting starts from 1 1 2 then n. Okay, so r dash plus 1 by r dash xm minus xw by r dash. Here m then up to n trace. Trace 1 to n. This is defined for trace r dash. R dash term is v by w. vapor coming in vapor coming in through a boiler through a boiler stripping section. This is stripping section line equation. Y is equal to q by q plus 1 plus 1 x minus x f q minus 1. Liquid convert into Vn plus 1 this is the residue collect in the below section. Below section means stripping section, stripping section. R dash plus 1 by R dash is equal to L by V, and minus 1 by R dash is equal to W by V. Total reflux condition France's equation N minimum plus 1 is equal to ln xt upon 1 minus xt 1 minus xw upon xw ln alpha average. Total reflux condition means we are not taking out the products in terms of distillate and residue. For pump Power is defined as delta P Q. Q is meter cube per second. Delta is Newton per meter square. So, this Newton meter per second. This is joule. So joule per second. Okay, power also defined as Q rho G H star. KQ meter cube by second, meter cube by kg G GH. G is meter per second square. This is meter. No, this is kilo per meter cube. Density, mass upon volume. Okay. So meter cube cos kilometer square by second cube. This is again a equation like a kilo force Newton, work done Newton meter, mass into acceleration. So kilometer square, kilometer per second square, meter per. So this terms is Newton meter per second. So this is joule per second. Okay guys, so this formula is also right. Q rho G H star. Power is W P Q rho. And shaft work is minus infinite WP. Okay. Power given, energy comes out as shaft work. Crystallizer. C plus L plus V. Vapor, mother liquor, feed. CXC LXL V is equal to 0. Bernoulli modified equation. PA by rho G plus ZA plus alpha A V average velocity square by 2G plus WP by G. P PB by rho G plus ZP plus alpha B square by 2G plus HF by G. This whole is in meter, is equal to meter. So WP has a relation minus a blue shaft, sorry, shaft work minus, okay, power is also defined as M mass flow rate into WP, and this is rho and see mass upon volume into Q WP. It comes out to be watt, okay, watt joule per second. Per second square, this comes out to be meter. Okay, so WP is meter square to second square, WP meter square by second square. Meter per second square, meter per second square, this whole term are in meter per second square. So PA is Newton per meter square, kilo by meter cube, then meter square on second square, Pascal, and Newton is kilometer per second square. Kilometer per second square, मीटर स्क्वायर मीटर क्यूब बाई किलो, किलो से किलो गया। सेकंड स्क्वायर मीटर स्क्वायर, this this cancel, second square। G is meter per second square, so this is meter, sorry, this is in meter only, you can see directly from this term is in meter, okay। So this so WP has a unit meter square upon second square। Again write it, PA by rho G plus ZA plus alpha A V square by 2G, this is A, WP by G to PP by rho G plus ZB plus alpha B VP square by 2G plus HF by G। HF by G is HF alone is delta P by rho, this whole term in meter is equal to meter। So we know the relations for pump, Q is directly proportional to N, head is directly proportional to N square, power is directly proportional to N cube। This we know, evaporation or and boiling of liquid in of liquid, so curve is like this. This is C, this is D, here maximum heat flux, this must be temperature, and this is heat flux, and D is Lander-Frost point. Lander-Frost point, minimum heat flux. We know that this, for a steam passing in a tube, Ts steam shall side, T1 temperature entering, m dot is a mass flow rate, water Ts, tube T2, temperature at point 2. So A naught outer area, this is our outer area, this is inside area, R naught outer radius, Ri inner radius, Ri R naught. So for overall heat transfer coefficient, 1 by 1 upon Hi plus R naught minus Ri Ai A Lm plus Ai upon A naught 1 upon H naught. This is Hi heat, convective heat transfer inside. This is H naught, outer convective transfer coefficient. This can be written in another form like Ui is equal to 1 by Hi Ai plus R naught minus Ri upon K A Lm plus 1 upon H naught A naught. This is 1 by 2 pi K L ln R2 by R1, or in case here R naught by Ri, and we know the relation that Ui Ai is equal to U naught A naught. How we add the resistance in case of currents? Similarly, we add for heat transfer coefficient like R2, R3, R4, R1, 1 by R2, 3, 1 by R2 plus 1 by R3. R total R1 plus R2, 3 plus R4. If we look out the if a insulation is there, is cylindrical, okay, Ti Ts and this is surrounding temperature. So it's a pipe, cylindrical pipe, okay. Q is equal to Ti minus T infinite R naught minus Ri upon Ka Lm, the logarithmic mean of area. This is Ri inner resistance, plus 1 upon H naught A naught R naught, outer resistance, Alm R naught minus Ri ln A naught by Ai 2 pi L. L is length of pipe. So heat is flowing from inside the pipe, inside the pipe to outside. So relation Ti This is Ti, this is Ts, Ti minus Ts upon Ri is equal to H naught A naught Ts minus T infinity. Okay, this relation can be useful. For hollow cylinder, Q is T1 minus T2 inside, and this is inside, this is outer temperature, 1 upon 2 pi KL ln R2 by R1. This is T2, this is T1, steady state. This is steady state. Parameters does not change with time. Okay, Q is equal to Ti minus T naught 1 upon T 1 upon HIA equal to T1 minus T2 upon L by Ka, T2 minus T naught upon 1 upon H naught A. Ti minus T naught Q whole resistance term chi A plus L by Ka plus L by Ka, Ti minus T naught, 1 by UA is equal to 1 by Hi A plus L by Ka plus 1 by H naught A. Ai is equal to A naught. Okay, this is overall heat transfer coefficient. We know that we can solve these complex systems like a system of linear algebraic equation. We can solve through Gauss-Seidel method. Non-linear algebraic equation we can solve through Newton-Raphson method. Newton-Raphson method. Ordinary differential equations can be solved by Runge-Kutta method. We know that for a stable system, all the phi controller function for GC, phi for F, G for process transfer function, it comes up to be must be is equal to 0, omega equal to omega at crossover frequency. We have a transfer function gs is equal to e minus theta s. S can be put as I omega minus theta I omega. So for this AR amplitude ratio is equal phi is minus tau d omega, and this is in radian. So radian to degree, to convert degree into degree, we have 180 by pi. This is a degree conversion factor. And tan inverse minus omega tau kc upon 0.1 s plus 1 or 3, n is equal to 3 if possible. N is 3, then 0.1 s. Gain margin can be calculated as AR amplitude ratio at omega is CO. AR overall transfer for equation, we can find AR for individually GC transfer function of controller, AR transfer function of process. F, I don't know what type of transfer, I am forgetting right now. We know trapezoidal gives the exact value for a first order linear function. Simpson rule gives the exact value of the integral for a third order polynomial. For integration is for when we do integration. Phi c is equal to 0 for constant kc. Let we discuss large value of Thiele modulus. What this implies? This is a rate constant, this is a diffusion constant. Long pores, its value is high, so diffuse L is a characteristic length volume upon area, so it comes out to be meter. So long pores, it shows a high value of empty shows long pores, fast surface phase reaction rate, slow diffusion inside pores, slow diffusion inside pores. As we directly see, empty is greater, so K should be greater, so K is related to reaction rate, so fast surface reaction rate, slow diffusion rate. Low pore diffusion rate. Okay. In CSTR, you know that when we put injected tracer, this is a pipe, there should be delay or lag at when we get a tracer. So ET is defined as 1 by tau CSTR e की power minus t upon tau CSTR. Okay. What is the meaning of coplanar? Coplanar means determinant is 0. A minus lambda I is equal to 0. Lambda comes out to be lambda 1 and lambda 2 are eigenvalues. Okay. Let's suppose we have a series 1 plus a square a cube a n minus 1. Sum is equal to 1 by s a and tends to infinite. Cauchy's homogeneous linear equation x is equal to et. Explanation of this I don't know clearly. I can, please comment below if you do, if you know guys. X dy by dx, we substitute these by d with this with d. Okay, dy x, similarly x d square y by dx square d minus 1 into y x cube d y dx cube d minus 1 minus 2 into y. This is Cauchy homogeneous cube d cube y by dxn cube plus 2x square d square y by dx square minus 2x dy by dx is equal to 0. CRDS, surface of sphere of radius r ix plus jy kz equal 3 by 4 pi r cube. We know that A B union C A union B union C, this is a 1 2 3. This is A C B, this is D, this is E G F. So this is, let's say, at least, let's say this is question 1, question 2, 3. At least one question is answered correctly. Means one answer can be correct, two answer can be correct, three answer can be correct. So at least one, not zero. Zero is not the case. So this means, so this combine means A plus B plus C plus G plus D plus E plus F. So NA B union C is equal to NA plus NP plus NC minus A intersection B plus B intersection C and A intersection C minus N A intersection B C. Okay. A intersection B means common in both A and B. So that is B. So that is B only. Total number of students can be N A union B union C and A bar B bar C bar. None answered correctly. At least answered one. Sorry, B. This refers to B plus D both. B plus D. This whole. And A intersection B.